Hidden beneath layers of ice and shadow, Antarctica guards secrets that could change everything we know about our planet. In this video, we journey to a world where glaciers the size of cities crumble, hidden mountains sleep beneath kilometers of ice, and ancient lakes may harbor life untouched for millions of years. Witness the colossal Thuait Glacier, teetering on the brink of collapse, and explore the mysterious Gamburtsev Mountains, Antarctica's lost Himalayas. Meet emperor penguins and seals, masters of survival in one of the harshest environments on Earth, and uncover subglacial lakes like Vosto, frozen worlds that could even hint at life on other planets. From fiery volcanoes beneath the ice to hidden waterways shaping our seas, Antarctica is a living laboratory of extremes. Don't miss this breathtaking journey into the frozen frontier. Like, share, and subscribe to Mysteries of Earth, and unlock the secrets that the ice has kept for millennia. Beneath the endless white expanse of West Antarctica lies one of the most formidable and precarious features on our planet, the Thuait Glacier. Stretching over 120 kilometers in length, this colossal river of ice flows silently toward the Amundsen Sea, its surface gleaming in the pale polar sunlight. To the casual observer, it might seem eternal, a frozen monument impervious to time. Yet beneath its icy exterior, Thuait is changing, retreating at a pace that has scientists both alarmed and deeply concerned. It is a glacier whose fate is tied inexorably to the health of our planet, and whose potential collapse could reshape coastlines and displace millions of people across the globe. Thuait Glacier is not merely ice. It is a living, moving entity, shaped by forces both above and below. Warm ocean currents creep beneath its floating ice shelf, eroding the base in a process known as basal melting. This hidden assault weakens the glacier's structure, allowing immense volumes of ice to surge seaward, where they eventually fracture and drift into the ocean. The speed of this retreat is staggering, accelerating over the past few decades as the planet's temperatures continue to rise. Each calving event, each icefall into the sea, is a reminder of the fragile balance that holds this frozen giant in place. Scientists consider Thuait Glacier a critical tipping point in the study of climate change. Its collapse could trigger a cascade effect, destabilizing neighboring glaciers and accelerating global sea level rise. Estimates suggest that if this single glacier were to disappear entirely, sea levels could rise by over 3 meters, a transformation with consequences for every coastal city on Earth. The enormity of its influence is matched only by the vast, forbidding landscape that surrounds it. Towering ice cliffs, snow-drifted plateaus, and the endless expanse of frozen silence. Despite its size and importance, Thuait remains largely unexplored. Its remote location and harsh environment make field research both difficult and dangerous. Yet modern technology, satellites, ice-penetrating radar, and autonomous sensors, has begun to unveil the glacier's secrets. Drilling cores reveal not only the age and movement of ice layers, but also the rates at which the glacier is melting and thinning. Each measurement adds another piece to the complex puzzle of how Antarctica's ice sheets interact with warming oceans, atmospheric changes, and global climate patterns. Standing at the edge of Thuait Glacier, one can feel both awe and a quiet dread. This is a landscape of extremes, beautiful and serene, yet holding a latent power capable of altering the world. As researchers continue to monitor its retreat, Thuait Glacier remains a symbol of the challenges we face in a warming world. It reminds us that even the coldest, most remote corners of Earth are not immune to human-induced change. The frozen giant flows onward, carrying with it the weight of history and the uncertain future of our seas. Beneath the icy surface of Antarctica, hidden from the eye, lies a process both subtle and devastating: basal melting. While the towering glaciers may appear static, these frozen giants are constantly in motion, shaped by forces far beyond the visible. At the interface where ice meets ocean, warm currents creep silently beneath floating ice shelves, eroding the foundations of these colossal structures. It is here, in the hidden depths, that glaciers begin to weaken, their stability compromised by heat that humans rarely see, yet its effects are felt across the globe. Basal melting occurs when ocean waters, slightly warmer than the freezing ice above, infiltrate the undersides of glaciers. Unlike surface melting, which is visible and gradual, this underwater erosion strikes from below, hollowing out the ice and lubricating its flow toward the sea. The glacier becomes less anchored to the land, sliding faster and more unpredictably, carving enormous chunks of ice into the ocean. Satellite images reveal this transformation in dramatic sequences. Vast ice shelves fracturing, towering cliffs tumbling into the waves, and the relentless advance of glaciers toward the sea, as if the ice itself is escaping the warming world. The forces driving basal melting are intertwined with the complex circulation of the Southern Ocean. Deep currents, carrying warmth from distant seas, funnel beneath ice shelves and carve channels beneath the glaciers. These currents are subtle, often invisible to those standing on the ice above, yet their impact is profound. As they erode the glacier's base, the ice above responds in kind, accelerating, thinning, and destabilizing neighboring ice sheets. The retreat is not merely a local phenomenon, it is a global warning. Sea levels rise as these glaciers release their frozen reservoirs, threatening low-lying cities and reshaping coastlines worldwide. Sigh. Scientific teams venture into this frozen expanse with a combination of courage and technology, deploying ice-penetrating radar, autonomous underwater vehicles, and oceanographic sensors to trace the paths of these invisible currents. They map the fractures in ice shelves, measure the thinning, and study how the under-ice melting interacts with the glacier's flow. Each piece of data builds a story of transformation, a story of ice slowly giving way to the warming oceans, of ancient glaciers facing a rapid, unprecedented change. Visualizing basal melting is like witnessing a hidden symphony of destruction. The gentle hum of ocean currents beneath a brittle ice shelf, the sudden crack of a glacier splitting, and the slow, inexorable slide of frozen giants into the dark waters. It is a reminder that the seemingly still landscapes of Antarctica are anything but permanent. They are alive, dynamic, and fragile. The science of basal melting illuminates the unseen mechanisms that drive ice loss and connects them directly to the future of the planet. How the warmth in far-off seas can reach into the heart of the Antarctic and trigger changes that ripple across continents and oceans. In understanding basal melting, we gain more than knowledge of ice physics. We gain perspective on the delicate balance of Earth's systems, on the invisible threads that link polar ice to global climate. Antarctica's glaciers are not just frozen relics of the past. They are sentinels of change, silently warning humanity of the consequences of a warming world. And in their retreat, we witness both the fragility and the power of our planet's frozen frontiers. In the frozen heart of Antarctica, life persists against the odds. Beneath the endless ice and snow, and through months of unbroken darkness, a remarkable cast of creatures thrives, testaments to nature's extraordinary resilience. Among the most iconic of these Antarctic inhabitants are the emperor penguins, silent sentinels of the winter ice. Towering over their smaller kin, these birds endure the bitter Antarctic winter, breeding during a season when temperatures can plunge below chapter 60 degrees Celsius, and the wind cuts like a blade across the ice. To survive, emperor penguins rely on a combination of biology and social cooperation. Beneath their dense plumage, a thick layer of insulating fat preserves precious heat. In the open expanse of the ice, they huddle together, forming tight, shifting colonies that function like a living furnace. The birds rotate positions, ensuring that no single individual bears the brunt of the cold. This remarkable social behavior, a delicate dance of endurance and cooperation, allows them to withstand a world that would claim nearly any other creature in seconds. Seals, too, have perfected survival in this harsh domain. The Weddell seal, a master of the Antarctic waters, dives to extraordinary depths in search of fish, squid, and other prey, sometimes plunging as far as 600 meters below the surface. Their thick blubber insulates against frigid waters, while their circulatory adaptations allow them to slow metabolism and conserve oxygen during long dives. On the surface, they haul out onto ice floes, basking in fleeting sunlight, yet ever ready to slip back into the cold, dark ocean that sustains them. Even larger denizens, like the blue whale, glide through the southern oceans, drawn to the nutrient-rich waters teeming with krill. These gentle giants, the largest animals to have ever lived, navigate a realm of extremes with an elegance that belie as the harshness surrounding them. Their migration, timed to the cycles of sea ice and food availability, is a profound reminder of life's intricate connection to the environment. Every creature in Antarctica has evolved extraordinary adaptations, from breeding strategies synchronized with the harshest months to migration patterns that exploit the fleeting abundance of food. These animals embody resilience in its purest form. Yet their existence is not without peril. As global temperatures rise and ice sheets retreat, their habitats change, threatening the delicate balance that has allowed life to flourish for millennia. Studying these animals is more than a cataloguing of species. It is a window into survival itself. Observing an emperor penguin colony huddle against the wind, a seal glide effortlessly beneath the ice, or a whale breach against the backdrop of a pale, frozen horizon, we witness life's capacity to endure, to adapt, and to thrive in extremity. Antarctica's wildlife is both fragile and tenacious, a living narrative of survival written in feathers, blubber, and fins. In the silence of this frozen continent, these animals remind us of the intricate web connecting all life. Their survival strategies inspire wonder, teaching us not only about the power of adaptation, but also the urgent need to protect the ecosystems that sustain them. In their resilience, we find a mirror to the perseverance required for life on a changing planet, and a testament to the astonishing diversity of Earth's natural world, even at the edge of the world. In the vast frozen expanse of Antarctica, where winter grips the continent with an unyielding hand, a remarkable story of endurance unfolds. Among the snow and ice, in temperatures that can plummet to 60 degrees Celsius, emperor penguins march with purpose, navigating the desolate landscape in a ritual as old as their species itself. These are the kings of the Antarctic winter, a symbol of nature's resilience and ingenuity. Unlike most birds, emperor penguins breed during the harshest months, when the sun disappears for weeks on end and the wind slices across the ice in relentless gusts. Each year, they embark on a grueling journey from open waters to the interior ice, traveling hundreds of kilometers to reach breeding grounds that will provide safety for their eggs. The very act of breeding in such extreme conditions is a testament to evolution's extraordinary design, balancing survival with the continuity of life. Once the eggs are laid, the real test begins. Male penguins carefully cradle their fragile offspring on top of their feet, covered by a fold of warm protective skin called a brood pouch. Here, the embryo remains shielded from the unrelenting cold, while the fathers endure weeks without food, relying solely on their thick layers of fat to sustain them. It is a period of remarkable patience and sacrifice, a silent vigil in a world that allows no mistakes. To withstand the brutal cold, emperor penguins have evolved dense, waterproof feathers and a blubber layer that insulates them against the frigid air. Yet even biology alone cannot suffice. Survival depends on community. In vast huddles that shift and swirl like living currents, penguins press against one another, exchanging the cold of the outer edges for the warmth at the center. This cooperative behavior is more than instinct. It is a choreography of endurance, a delicate balance of giving and taking that all allows the colony to survive when the environment would otherwise claim them. Every day is a battle against the elements. Every step across the icy plains, a measure of determination. The wind howls, the ice stretches endlessly, and yet the penguins endure, a living testament to the power of adaptation. When the eggs finally hatch, a new generation emerges into a world still dominated by winter's grip.
nurtured by a society that has perfected the art of survival through centuries of evolution. Emperor penguins are more than a species surviving in extreme cold. They are a symbol of life's tenacity in the face of adversity. Their story teaches us about resilience, cooperation, and the extraordinary ways nature overcomes even the harshest challenges. Observing their march across the icy landscape, the careful balance of huddling and warmth, and the tender care of their young, we witness a living drama, an intimate portrait of life at the edge of the world. In their silent, majestic endurance, emperor penguins remind us of the beauty and fragility of life in Antarctica. They are kings not only of the Antarctic winter, but of adaptation itself, guardians of a frozen wilderness that continues to awe and inspire anyone who dares to study its wonders. In every feather, every coordinated step, and every huddle, the emperor penguin narrates a story of survival that is as profound as the icy continent they call home. Beneath the frozen surface of Antarctica, where the water is as dark and cold as the endless winter sky, a group of formidable hunters glides with unmatched grace and precision. Antarctic seals, masters of survival in one of the harshest environments on Earth, navigate the icy waters with a combination of skill, strength, and adaptation that has been honed over millennia. The Weddell seal, leopard seal, and crab-eater seal are among the most iconic residents of this frozen wilderness, each uniquely equipped to endure the extreme cold and hunt in a world dominated by ice. Their thick layers of insulating blubber act as a natural thermal shield, preserving body heat in waters that can chill to 2 degrees Celsius. Even in such frigid temperatures, seals move through the ocean with remarkable efficiency, their streamlined bodies reducing resistance and allowing them to glide silently beneath the ice. Diving is where these creatures truly demonstrate their mastery. Weddell seals can descend to depths of 600 meters in search of fish, squid, and crustaceans, holding their breath for over an hour at a time. Their blood carries oxygen more efficiently than most mammals, and their muscles are designed to function with minimal oxygen, allowing them to explore the shadowy depths where few creatures dare to venture. Leopard seals, on the other hand, are apex predators, powerful and agile, capable of ambushing penguins and other seals with deadly precision. Each movement is purposeful, a dance choreographed by evolution to survive in a world that is both beautiful and unforgiving. But survival extends beyond hunting. The Antarctic landscape is ever-changing, with sea ice expanding in winter and retreating in summer. Seals rely on a combination of instinct and learned behavior to navigate these shifts. They use breathing holes in the ice, returning to familiar spots time and again, and even resting on ice floes to escape predators or conserve energy. In this delicate balance of ice and ocean, life is a continuous negotiation with the elements. Seals are not just solitary hunters. Their social behaviors are equally remarkable. Mothers nurse pups on the ice, balancing warmth, nutrition, and protection against the harsh environment. Pups are born with soft white fur, which provides temporary insulation, but it is the mother's constant care and the seal's blubber that ensure their survival through the first critical weeks. Every dive, every hunt, every haul out onto the ice is a testament to the extraordinary adaptations that allow life to thrive in Antarctica. These creatures remind us that survival is not merely a struggle. It is a story of ingenuity, resilience, and harmony with a world that demands the utmost respect. As we watch a Weddell seal disappear beneath the ice, a leopard seal glide silently through the dark waters, or a crab-eater seal navigate the shifting ice floes, we are reminded of the fragile beauty of this frozen ecosystem. Antarctic seals are not only survivors, they are guardians of the icy depths, living proof that life can flourish even at the edge of human comprehension. In their strength, grace, and endurance, they embody the remarkable spirit of Antarctica itself. Beneath Antarctica's vast, frozen expanse lies a world almost entirely hidden from human eyes, the Ellsworth Subglacial Highlands. Towering peaks and ridges, remnants of mountains formed millions of years ago, are buried beneath more than 4,000 meters of relentless ice. Here, in this silent, frozen world, time seems suspended, and the secrets of Earth's distant past lie locked beneath layers of ice that have persisted through eons. The Ellsworth Highlands are thought to be remnants of ancient mountain chains, older than the ice that now engulfs them. Their rugged peaks, once exposed to sun and wind, now lie in darkness, hidden beneath kilometers of glacial ice. Scientists believe that these mountains may hold geological records that could illuminate the story of Antarctica long before it became a frozen continent. Fossils, mineral deposits, and ancient rock formations may still whisper tales of climates far warmer than today, when life thrived on this land, now trapped beneath ice. Despite their significance, studying these mountains is no simple task. The sheer thickness of the ice and the extreme Antarctic conditions make direct exploration impossible. Instead, researchers rely on cutting-edge technologies, including ice-penetrating radar, seismic surveys, and satellite imaging to map the hidden terrain. With every new scan, the contours of these ancient peaks begin to emerge, revealing jagged ridges, deep valleys, and previously unknown subglacial lakes that may harbor microbial life isolated for millions of years. The Ellsworth Highlands are more than just geological relics. They are a key to understanding Earth's tectonic past. They may hold clues about the formation of ancient supercontinents, the shifting of ice sheets over millions of years, and the forces that continue to shape Antarctica today. Even as climate change accelerates the melting of ice across the sea continent, these hidden mountains may influence how glaciers flow, subtly guiding the movement of ice and affecting the stability of surrounding regions. There is a profound sense of mystery in imagining what lies beneath the ice. Could these ancient rocks reveal fossils of life that existed long before the ice sheets arrived? Could they contain evidence of ecosystems that survived in climates vastly different from today's polar desert? The Highlands are a time capsule, holding stories that span millions of years, preserved in silence beneath the cold, unyielding ice. As we peer into this hidden world, guided by the soft pulses of radar and the quiet hum of satellites orbiting above, we are reminded of Antarctica's fragile beauty and the resilience of Earth itself. The Ellsworth Subglacial Highlands are a testament to the planet's hidden wonders, a realm where ancient mountains lie shrouded in ice, waiting patiently to tell their story. For scientists and explorers, each discovery is a revelation, a chance to glimpse the Earth as it once was and to understand the forces that continue to shape its frozen frontier. In this secret world beneath kilometers of ice, the past endures, untouched yet alive in its geological memory, inviting us to uncover the silent mysteries of Antarctica's hidden peaks. Beneath the thick frozen surface of Antarctica lies a hidden world, cloaked in darkness and mystery, its subglacial lakes. Among the most enigmatic is Lake Vosto, a vast body of water trapped beneath more than 4 kilometers of ice. Shielded from sunlight, isolated from the atmosphere, and locked in extreme cold and high pressure, these lakes represent some of the last untouched ecosystems on Earth. For millions of years, life, if it exists there at all, has persisted in complete isolation, offering a glimpse into survival in conditions that seem almost otherworldly. The story of these lakes begins with their formation. As ice sheets slowly advanced across the continent over millennia, they sealed off pockets of liquid water beneath, creating natural laboratories frozen in time. The pressure from the overlying ice prevents the water from freezing completely, even as temperatures plummet well below 50 degrees C. Scientists believe these isolated waters could harbor microbial life that evolved independently, providing an unprecedented window into the adaptability of life in extreme environments. Exploring Lake Vosto is no simple task. In 2012, researchers undertook a daring drilling mission to penetrate the ice and collect samples from the lake's surface. Extreme caution was required to avoid contaminating this pristine ecosystem. Every drop of water retrieved offered the tantalizing possibility of discovering ancient microbes, organisms that may have thrived in complete darkness for millions of years, sustained by chemical energy rather than sunlight. These lakes are not merely isolated curiosities.
they hold profound scientific significance. Understanding how life survives in such harsh conditions can illuminate Earth's past, revealing how ecosystems might have endured dramatic climate shifts. Beyond our planet, subglacial lakes serve as analogues for extraterrestrial environment. Planetes such as the icy moons of Jupiter and Saturn, Europa and Enceladus, where liquid water may exist beneath frozen surfaces. Could microbial life exist there, as it has here, in utter isolation for millennia? The extreme conditions of Lake Vosto are both a challenge and a wonder. The waters are dark, cold, and under immense pressure, yet within them may reside life forms that have never seen the sun. These microbes, if present, would have adapted in extraordinary ways, perhaps using chemical reactions with the minerals in the bedrock as energy, showing nature's capacity for resilience and ingenuity. As scientists continue to study these subglacial lakes, every discovery reminds us of the fragility and perseverance of life. Antarctica's hidden waters are a living testament to the mysteries still held by our planet. They challenge our understanding of where life can exist and inspire awe at the silent, persistent processes unfolding beneath the ice. Lake Vosto and its sister subglacial lakes are silent sentinels, preserving secrets of Earth's past and offering clues about the potential for life beyond our world. In their icy depths lies a story of isolation, survival, and the astonishing adaptability of life, waiting patiently for us to uncover it. Deep beneath Antarctica's icy surface lies a world untouched by time. Lake Vosto. Buried beneath over 4 kilometers of solid ice, this subglacial lake has remained isolated for millions of years, a secret ecosystem locked away from the outside world. Shielded from sunlight, insulated from the atmosphere, and subjected to immense pressure, Lake Vosto presents an alien-like environment, as if plucked from another planet and frozen in stasis. To scientists, it is both a mystery and a window into the resilience of life in extreme conditions. The journey to understand Lake Vosto begins with its isolation. For millennia, the advancing Antarctic ice sheets encased the lake, sealing off any connection to rivers, oceans, or even the air above. Temperatures here plunge far below freezing, yet the lake's immense pressure keeps its waters from solidifying completely. The darkness is absolute, and the environment is one of the harshest imaginable. Yet, paradoxically, this very isolation makes it a potential sanctuary for life, one that has evolved undisturbed, shielded from Earth's changing climate and human interference. Exploration of Lake Vosto is a meticulous and high-stakes endeavor. In 2012, scientists undertook a careful drilling operation to penetrate the ice, risking contamination to study its waters. Samples collected hinted at the possibility of microbial life, organisms that may have existed in isolation for millions of years, relying not on sunlight, but on chemical reactions with minerals in the lakebed for energy. The potential implications of these findings are staggering. Life could endure in complete darkness, adapting to conditions that would be lethal elsewhere on Earth. Lake Vosto is more than an isolated lake. It is a natural laboratory for studying extreme ecosystems. The microbes here, if confirmed, would reveal life's capacity for survival under pressures, temperatures, and chemical conditions that mirror otherworldly environments. In this sense, Lake Vosto serves as a model for astrobiology, providing clues about the possibility of life on icy moons like Europa and Enceladus, where oceans may exist beneath frozen crusts. The lake's alien-like environment inspires both awe and reflection. The silence, the darkness, the relentless cold. It is a world completely cut off from the rhythms of the surface. Any life forms within it must be exquisitely adapted, living in near-complete darkness, surviving on limited nutrients, and withstanding immense pressures. It is a testament to the adaptability and tenacity of life, enduring in places we once thought uninhabitable. As exploration continues, Lake Vosto remains a frozen time capsule, preserving secrets of Earth's past while hinting at the possibilities of life beyond our planet. Each discovery brings us closer to understanding how life can persist in isolation and extreme conditions, reminding us that even beneath layers of ice, the Earth holds worlds waiting to be discovered. In Lake Vosto, the line between science and the extraordinary blurs, and the frozen depths quietly guard their ancient mysteries, inviting us to uncover the story of life in its purest and most resilient form.
Beneath the seemingly endless white expanse of East Antarctica lies a hidden world of staggering scale and silent grandeur, the Gamburtsev Mountains. Completely buried beneath more than 4 kilometers of ice, these mountains are often called Antarctica's Lost Himalayas, a vast range of peaks and valleys hidden from human eyes. Stretching over 1,200 kilometers, their jagged ridges and high plateaus remain shrouded in mystery, their secrets frozen in time beneath the relentless ice. The Gamburtsev Mountains are thought to have formed hundreds of millions of years ago, long before Antarctica became the frozen continent we know today. Once part of an ancient supercontinent, these peaks bore witness to dramatic shifts in Earth's crust, the drifting of continents, and the ebb and flow of prehistoric oceans. Today, their ancient rocks may hold fossilized remnants of life from an era when Antarctica was temperate, teeming with forests, rivers, and creatures now lost to history. Yet, all of this remains hidden, preserved beneath the ice, awaiting discovery. Though invisible to the naked eye, the Gamburtsev Mountains play a profound role in shaping Antarctica's ice sheets. The peaks influence how glaciers flow, guiding rivers of ice along their hidden valleys and controlling the movement of some of the continent's largest ice masses. These mountains act as silent architects of the frozen landscape, their ridges and valleys determining the patterns of ice accumulation, melting and carving that affect the entire continent. Understanding their structure is essential to predicting how Antarctica's ice will respond to climate change and rising global temperatures. Exploring the Gamburtsevs is a feat of science and technology. Researchers employ ice-penetrating radar, seismic imaging, and satellite observations to map the contours of these hidden mountains. Each survey reveals new insights. Subglacial valleys carved by ancient rivers, peaks rivaling the Alps in height, and the thick ice that both shields and conceals them. Every discovery underscores the mountain's geological significance, hinting at a time when life flourished in regions now buried under kilometers of ice. The mystery of the Gamburtsev Mountains extends beyond their geology. Could fossils and mineral deposits within these peaks provide evidence of Antarctica's lush past? Could ancient ecosystems lie frozen beneath the ice, offering clues to Earth's climate history and evolution? Scientists continue to ask these questions, drawn by the possibility of uncovering stories written long before humans walked the planet. In their hidden magnificence, the Gamburtsev Mountains inspire awe and reflection. They remind us that even in the coldest, most remote corners of the world, Earth preserves vast chronicles of its own history. Beneath the ice, these lost Himalayas lie in patient silence, shaping the continent above, while safeguarding secrets from a time when Antarctica was a land of life, warmth, and possibility. As exploration and technology advance, humanity inches closer to revealing the full story of the Gamburtsev Mountains, a frozen cathedral of Earth's ancient past, waiting to speak once again. Beneath the frozen expanse of East Antarctica lies one of the planet's most mysterious and forbidding landscapes, the Denman Glacier Trench. Hidden beneath a thick blanket of ice, this immense trench plunges to depths exceeding 3,500 meters, making it even deeper than the Grand Canyon. Its sheer scale is almost incomprehensible, a silent testament to the immense forces of ice, tectonics and time that have carved this hidden abyss. In this remote and inhospitable corner of the world, temperatures often fall below 50 degrees Celsius, and fierce winds whip across the ice, creating an environment where few humans have ventured and fewer have survived. The Denman Glacier Trench is not merely a geographical marvel, it is a living laboratory for understanding Earth's ancient past. Its depths are sculpted by the movement of glaciers over millions of years, ice slowly grinding away the bedrock beneath, while carving vast valleys and hidden basins. Scientists speculate that subglacial lakes, isolated from sunlight and atmosphere for millions of years, may lie within these hidden depths. These lakes could harbor microbial life forms that have evolved entirely independently from the surface world, preserving ecosystems frozen in time. Such discoveries could provide vital insights into life's resilience in extreme environments, and even offer analogues for life on distant worlds such as Mars or Europa. Exploration of the Denman Trench requires a delicate blend of technology and scientific ingenuity. Ice-penetrating radar and seismic surveys allow researchers to map its contours without disturbing its fragile environment. Each data point reveals a hidden world of peaks and valleys beneath kilometers of ice, unveiling a complex network of channels where ice and water interact. Understanding this interplay is crucial. The stability of the Denman Glacier has direct consequences for global sea level rise. Should this icy giant retreat or collapse, it could accelerate the flow of neighboring glaciers into the sea, contributing to catastrophic rises that would reshape coastlines worldwide. Beyond its immediate environmental impact, the Denman Glacier Trench holds secrets of Earth's distant past. Fossilized organisms, ancient sediments, and mineral deposits trapped beneath the ice could tell the story of a time when Antarctica was a temperate land teeming with life and vegetation. Every layer of ice and rock is a page in a history book millions of years in the making, waiting for careful scientific study to unlock its narrative. Standing on the surface above this icy abyss, one is struck by a profound sense of humility and wonder. Here lies a world untouched, where time has slowed, and the forces of nature continue to shape the earth in silence. The Denman Glacier Trench is more than a trench. It is a gateway into the hidden mechanisms of our planet, a reminder that beneath even the coldest, most desolate landscapes, life, history, and mystery endure. As exploration continues, the trench promises to reveal secrets that could reshape our understanding of Antarctica, the history of life, and the delicate balance of Earth's ice-clad frontier. Antarctica, the vast frozen expanse at the southernmost edge of the world, has long been a symbol of permanence, a continent seemingly untouched by time. Yet beneath the seemingly unyielding ice, profound changes are underway. The relentless warming of our planet has begun to rewrite the story of this icy wilderness, triggering a cascade of transformations that resonate far beyond the Antarctic coast. Here, in this land of extremes, the effects of climate change are perhaps most starkly visible. Glaciers that have persisted for millennia are retreating at unprecedented rates. Colossal rivers of ice, once steady and seemingly eternal, now fracture and flow into the Southern Ocean with alarming speed. Among them, glaciers like Thuait and Denman act as critical bellwethers. As they thin and collapse, the ice they once held back surges into the sea, contributing directly to global sea level rise. Scientists warn that even modest losses in Antarctic ice can ripple across the planet, submerging coastal cities, altering weather patterns, and displacing millions of people. The melting of these glaciers is not just a story of water and ice, it is a story of ecosystems in flux. As sea ice retreats, habitats for penguins, seals, and other Antarctic wildlife shrink, forcing animals to adapt or perish. Food chains are disrupted as krill populations, the foundation of the Southern Ocean ecosystem, fluctuate with the changing ice. Even the most resilient species face new pressures, highlighting the delicate balance that governs life in one of the harshest environments on Earth. Beneath the ice, the consequences of warming are equally profound. Subglacial lakes and hidden mountain ranges, long isolated from the surface, now feel the influence of melting ice. Changes in ice flow can destabilize ancient glaciers, revealing landscapes that have been locked away for millions of years. So transformations are not just geological, they are emblematic of a tipping point, a moment when the stability of the Antarctic ice sheet hangs in the balance. Yet amid this crisis, Antarctica remains a source of awe and inspiration.
its ice shelves glittering in the pale sun, and its towering glaciers, slowly shifting like frozen rivers, remind us of the power and fragility of nature. Scientific exploration here is urgent and illuminating, revealing the mechanisms of change while offering a window into the interconnectedness of our global climate system. The story of climate change in Antarctica is both a warning and a call to action. It reflects the consequences of human activity on a planetary scale, and yet it also offers a chance for understanding, mitigation, and stewardship. Every ice core drilled, every glacier monitored, and every ecosystem studied tells us more about the fragile equilibrium that sustains life on Earth. In the frozen heart of Antarctica, the world witnesses both the majesty of nature and the urgent need to protect it, standing on the precipice of change, where the fate of ice, sea, and life itself hangs in delicate balance. Amidst the endless white expanse of Antarctica, where ice stretches uninterrupted to the horizon, a surprising and almost paradoxical force of nature asserts itself. Mount Arabus. Rising 3,794 meters above the frozen terrain of Ross Island, this volcanic giant pulses with life, its molten heart a stark contrast to the icy world that surrounds it. While the continent is known for its extremes of cold and desolation, Mount Arabus is a reminder that beneath even the coldest surfaces, the Earth's inner fire continues to shape and sculpt the planet. At its summit, a persistent lava lake glows like a molten eye against the frigid Antarctic night. Streams of liquid rock shift and churn with a hypnotic rhythm, casting reflections across nearby snowfields and ice cliffs. Plumes of volcanic gas rise into the thin, crisp air, mingling with the swirling Antarctic winds, creating an ever-changing spectacle of heat, smoke, and light. Here, in the midst of extreme cold, the dynamics of the Earth's mantle are revealed in real time, offering scientists a rare window into the forces that drive the planet from deep below. The activity of Mount Arabus is not just visually striking. It has profound geological significance. Its lava flows interact with the surrounding glaciers in subtle yet consequential ways. Heat from the volcano can accelerate ice melt locally, influencing the flow of nearby glaciers and altering the landscape around it. These interactions highlight the delicate balance between fire and ice, a relationship that has persisted for millennia and continues to shape the Antarctic environment in ways both dramatic and subtle. Studying Mount Arabus allows scientists to explore processes that are otherwise invisible beneath the Earth's crust. The chemistry of its lava, the behavior of its gases, and the rhythm of its eruptions all provide clues about the composition of the mantle and the movements that drive tectonic activity. This volcanic activity also serves as a natural laboratory for understanding how heat and pressure interact with ice, an insight that becomes increasingly important in a warming world where ice sheets are under stress from both climate change and geological forces. Beyond science, Mount Arabus captivates the imagination. Against a backdrop of endless ice and snow, the sight of molten rock and glowing lava is both surreal and awe-inspiring. It is a vivid reminder of the dynamic, ever-changing nature of our planet, where extremes coexist and the forces of creation and destruction are intertwined. Mount Arabus stands as a testament to the complexity and resilience of Earth. Even in the most inhospitable and frozen corners of the world, life, geological, chemical, and ecological, persists, adapting and evolving around extreme forces. The fiery heart of Antarctica continues to captivate scientists, explorers, and dreamers alike, revealing secrets about our planet's inner workings and reminding us of the astonishing power that lies beneath the seemingly silent ice. Stretching across millions of square kilometers, the Antarctic ice sheets stand as silent sentinels over the frozen continent, a vast white expanse so immense it seems to hold the weight of the world upon its shoulders. Divided into East and West Antarctica, these colossal ice masses are not mere glaciers. They are living, breathing guardians of Earth's climate. Each year, they store trillions of tons of frozen water, regulating ocean levels and acting as a thermostat for the planet, their frozen surfaces reflecting sunlight and moderating global temperatures. East Antarctica, a seemingly endless plateau of ice and rock, is the continent's fortress. Its icy ridges stretch over 4,000 meters above sea level in places, shielding ancient mountains buried beneath. Here, the ice has persisted for millions of years, a testament to Earth's slow geological rhythm. In contrast, West Antarctica is a more fragile landscape, its ice sheets grounded on bedrock below sea level and particularly vulnerable to the warming oceans that lap at its hidden glaciers. The contrast between these two regions illustrates both the resilience and vulnerability of our planet's frozen frontier. Yet the ice sheets are not static. Beneath the frozen surface, immense rivers of ice flow toward the ocean, carving valleys and reshaping the landscape over millennia. In West Antarctica, these flows have accelerated in recent decades, driven by warm ocean currents melting glaciers from below. Each ton of ice that slips into the sea contributes to rising sea levels, threatening distant coastlines with floods and storms, and reminding the world that these remote sheets are intimately linked to human life thousands of kilometers away. The ice sheets also play a critical role in regulating climate through a delicate balance of reflection and insulation. Their bright surfaces reflect vast amounts of sunlight, hellies, ping to cool the Earth, while their frozen mass stores carbon and influences atmospheric circulation. Changes in this frozen ecosystem ripple far beyond Antarctica, affecting rainfall patterns, ocean currents, and global weather systems. The ice sheets are, in essence, a keystone of the Earth's climate, and their stability is intertwined with the planet's very habitability. Exploration and study of these colossal ice masses are challenging. Extreme cold, blizzards, and vast remoteness make research perilous. Yet scientists persist, drilling ice cores that reveal ancient climates and deploying satellites that track ice movement in real time. Each discovery underscores the magnitude of what is at stake. The Antarctic ice sheets are not just frozen landscapes. They are archives of Earth's history and regulators of its future. As the planet warms, the guardians of Antarctica are under threat. Melting ice, retreating glaciers, and thinning sheets signal that even the mightiest frozen fortresses are not immune to change. Yet within their silent glacial depths lie lessons about resilience, adaptation, and the delicate balance of life on Earth. The Antarctic ice sheets are both shield and storyteller, a frozen testament to the forces that shape our world and a warning of what may come if they falter. Beneath the endless whiteness of Antarctica, far from the reach of the sun, lies a hidden world teeming with life invisible to the naked eye. In the frigid darkness beneath kilometers of ice, microbial communities persist, surviving in conditions that would seem utterly inhospitable. These extraordinary organisms thrive in subglacial lakes, trapped beneath massive ice sheets for millions of years, isolated from the surface world. Here, sunlight never penetrates, temperatures hover just above freezing, and pressures reach extremes few life forms can endure. Yet, life endures. These microbes have evolved remarkable adaptations to survive in complete darkness. Lacking photosynthesis, they rely on chemical energy drawn from the rocks and sediments beneath the ice. Some metabolize minerals, others break down ancient organic matter preserved in frozen sediments, while a few even harness hydrogen and sulfur compounds released from geothermal activity below. Every microscopic cell represents a triumph of biology against the odds, a testament to nature's ingenuity in finding a way to persist where life seems impossible. The discovery of these subterranean ecosystems has transformed our understanding of life on Earth. Scientists drilling through kilometers of ice into lakes like Lake Vosto have uncovered microbial communities that appear to have evolved independently, cut off from the wider biosphere for millennia. Each sample hints at extraordinary resilience. DNA sequences adapted to low temperatures, low nutrient availability, and extreme isolation. These hidden life forms are living fossils, offering glimpses into the Earth's distant past and the extraordinary lengths to which life will go to survive. Yet the significance of these microbes extends far beyond our planet. By studying life beneath Antarctica's ice, researchers gain insight into how life might exist in similarly harsh environments elsewhere in the solar system. Subsurface oceans on moons like Europa or Enceladus, or the frozen regolith of Mars, may harbor life comparable to these Antarctic extremophiles. Every microbe discovered beneath the ice becomes a small bridge between our world and the possibilities of life beyond Earth, demonstrating that life does not require sunlight to flourish. It merely requires adaptation. Exploring these hidden realms is perilous, demanding precision and care. Scientists must prevent contamination while drilling deep into ancient ice, using sterilized equipment to capture authentic samples. Each finding is a window into a parallel biosphere, a reminder that life exists not only in the visible, sunlit world, but also in the unseen, silent depths beneath. The story of these microbes is a story of resilience, persistence, and quiet survival. In a place of perpetual darkness, where human presence is fleeting and rare, life endures against all odds. Beneath Antarctica's frozen surface, in this hidden microbial universe, the resilience of life whispers a profound truth. Where conditions are extreme, adaptation is supreme, and the boundaries of survival are far broader than we could ever imagine. Beneath Antarctica's vast sheets of ice lies a record of a world long forgotten, a frozen archive of Earth's ancient history. Buried beneath kilometers of ice, fossils, rocks and sediment layers tell a story of a continent that was once verdant, warm and teeming with life. Today, this frozen land is inhospitable, yet it holds echoes of a prehistoric world, captured and preserved in the ice like pages of a timeless book. Geologists and paleontologists venturing into this icy wilderness have uncovered fossils of plants, ancient forests, and even traces of prehistoric animals, hinting at a climate radically different from the extreme cold of today. Sediments extracted from beneath the ice sheets reveal periods when Antarctica was part of a supercontinent, connected to what is now South America, Africa, and Australia. In these warmer eras, life flourished, from towering ferns to vast swampy wetlands, leaving behind fossils that serve as a testament to Earth's ever-changing climate. Rocks, too, hold their own silent stories. Layers of sediment reveal volcanic activity, shifting tectonic plates, and ancient shorelines that no longer exist. By analyzing isotopes within these rocks, scientists can reconstruct temperature patterns, atmospheric conditions, and the rhythm of ancient ice ages. Each layer acts as a chapter in the continent's long and dynamic history, a chronicle of transformations spanning millions of years. The frozen nature of Antarctica provides a unique form of preservation. Encased in ice, fossils remain remarkably intact, shielded from erosion and decay. This pristine archive allows researchers to examine prehistoric ecosystems with extraordinary clarity. By studying these remnants, scientists gain insight into the resilience and vulnerability of life in the face of climatic upheaval, a mirror for understanding the challenges posed by today's rapidly warming world. Yet these ancient secrets are not easily accessed. The continent's remoteness, extreme cold, and unpredictable weather make fieldwork perilous. Specialized drilling techniques and ice-penetrating radar allow scientists to peer beneath the frozen surface, uncovering hidden layers that have been undisturbed for millions of years. Each discovery, whether a fossilized leaf or a sediment core, is a doorway into Earth's deep past, revealing climates that once nurtured life in a land now dominated by ice. As explorers and researchers piece together Antarctica's geological story, a profound narrative emerges, a tale of transformation, survival, and the power of nature over eons. The frozen secrets preserved in the ice remind us that our planet's climate has always been dynamic, shaped by forces both gradual and cataclysmic. In the heart of Antarctica, history waits silently beneath the ice, inviting us to uncover its lessons, to understand the past, and to reflect on the fragility and resilience of life on a planet that is ever-changing. Beneath Antarctica's seemingly endless sheets of ice lies a secret world of liquid movement, a hidden network of rivers and lakes flowing silently under kilometers of frozen surface. These hidden waterways, unseen by human eyes, are a crucial force shaping the continent's icy landscape. Meltwater, created by seasonal warming and geothermal heat from beneath the Earth's crust, carves paths beneath the ice, lubricating its base and influencing the flow of massive glaciers. Imagine a river running beneath a sheet of ice thousands of meters thick, carrying meltwater from the interior toward the coasts. These subglacial rivers act as arteries, connecting lakes and channels in a hidden hydrological system. One of the most remarkable aspects of these waterways is their ability to accelerate ice movement. As water seeps beneath glaciers, it reduces friction between ice and bedrock, allowing colossal sheets of ice to glide faster toward the sea, feeding icebergs and contributing directly to sea level rise. Meltwater lakes beneath the ice, like the famous Lake Vosto, are isolated pockets of liquid that have persisted for millions of years. These lakes serve as time capsules, preserving both the chemical history of the continent and potentially ancient microbial life adapted to extreme cold and pressure. Scientists studying these lakes have discovered that they play a key role in regulating ice sheet dynamics. Seasonal filling and draining of these subglacial lakes can trigger shifts in ice flow, sometimes releasing sudden pulses of ice into the ocean. The hidden waterways are not only scientific curiosities, they are a critical factor in understanding global climate change. As the planet warms, surface melt increases, feeding more water into these subglacial systems. The added lubrication can hasten glacier collapse, amplifying the rate at which Antarctic ice enters the ocean. His is a delicate and complex system, where small changes in temperature or ice thickness can ripple through the continent, affecting distant glaciers and ultimately influencing sea levels across the globe. Explorers and scientists use radar, satellite imagery, and ice-penetrating sonar to map these hidden networks, revealing the intricate pathways carved over millennia. The visual is striking. A frozen desert above, yet beneath, a dynamic, flowing world. Rivers winding in silence, lakes pulsing with ancient water, all beneath the seemingly immovable ice. Antarctica, often perceived as a static, lifeless expanse, is in truth a continent alive with movement, where hidden waterways silently sculpt the fate of ice and oceans alike. Understanding these subglacial systems is not just a matter of curiosity. It is a race against time. The stability of Antarctica's ice sheets, the survival of species dependent on sea ice, and the fate of coastal cities around the world are all intimately linked to these hidden waters. In the frozen silence beneath the ice, rivers and lakes whisper the story of a dynamic, ever-changing Antarctica, a world where life, movement, and the forces of nature continue their quiet, powerful work, shaping the destiny of our planet. Antarctica is a land of extremes, a world where temperatures plunge below 60 degrees, where relentless winds scour the ice, and where sunlight disappears for months at a time. Yet, in this frozen wilderness, life not only survives, it thrives. The secret to survival in the harshest environment on Earth lies in extraordinary adaptations honed over millennia, a delicate balance of biology, behavior, and sheer resilience. Among the most iconic inhabitants are the emperor penguins. Each winter, these remarkable birds gather in dense huddles, forming a living fortress against the bitter Antarctic cold. As temperatures plummet, individual penguins take turns rotating from the warm center to the freezing periphery, conserving energy while shielding each other from icy winds. Their thick layers of feathers and insulating fat are a marvel of natural engineering, allowing them to endure the brutal winter while raising their young on the shifting ice. Seals, too, demonstrate astonishing adaptation. Weddell and leopard seals plunge hundreds of meters beneath the ice to hunt for fish and squid, their streamlined bodies cutting through sub-zero waters with ease. A thick layer of blubber keeps their core temperatures stable, while physiological adaptations allow them to hold their breath for extraordinary lengths of time. Every dive, every hunt, is a testament to survival under conditions that would overwhelm most other creatures. Even smaller organisms, like Antarctic krill, endure freezing waters by producing natural antifreeze proteins, a biochemical shield that prevents ice crystals from forming in their bodies. These tiny creatures form the foundation of the Antarctic food web, sustaining penguins, seals, and whales alike. Migratory strategies also play a role. Some species time their life cycles to follow seasonal blooms of plankton or fish, synchronizing their hunting and breeding to the rhythms of this frozen ecosystem. Predatory behaviors are equally fascinating. Leopard seals, solitary hunters of the pack ice, use stealth and patience to ambush prey, while killer whales coordinate as teams, demonstrating remarkable intelligence and adaptability. Every aspect of life here, from the synchronized huddles of penguins to the hunting tactics of seals and whales, is a strategy forged to overcome scarcity, cold, and isolation. The lessons from Antarctic adaptations extend beyond survival. They are a reflection of life's capacity to endure in extreme conditions. Each creature, each behavior, is a story of resilience, a narrative of life's persistence in the face of adversity. In this silent, icy world, the struggle for existence unfolds with elegance, rhythm, and purpose. Observing these strategies, we are reminded that survival is not merely about enduring harsh conditions. It is about thriving through ingenuity, cooperation, and extraordinary adaptation. Antarctica's wildlife, in all its diversity and ingenuity, challenges our understanding of life on Earth. It inspires awe and humility, revealing the remarkable ways in which nature persists against impossible odds. In the coldest place on the planet, life survives. And in surviving, it teaches us the profound resilience of the natural world. Beneath the seemingly endless expanse of ice that blankets Antarctica lies a hidden world, mountains older than human history, valleys carved over millions of years, and lakes sealed from the surface for eons. For centuries, this frozen continent resisted human curiosity, its secrets locked beneath kilometers of ice, a silent fortress untouched by the outside world. Today, technology is our key to unlocking these mysteries, allowing scientists to peer into landscapes long hidden from sight. Ice-penetrating radar has become one of the most powerful tools in this exploration. Pulses of radio waves are sent through thick layers of ice, reflecting back images of the land beneath. Mountains, ridges, and ancient valleys emerge from the data like ghostly silhouettes, revealing the contours of a world that has remained invisible for millennia. With every scan, the subglacial topography of Antarctica comes into sharper focus, allowing researchers to map regions that no human has ever set foot on. Seismic surveys complement this view, using vibrations sent through the ice and rock to uncover geological structures. The echoes of these signals tell stories of tectonic forces, past glaciations, and even hidden water reservoirs. Scientists interpret these vibrations like an orchestra of Earth's movements, decoding the rhythms and pulses of a frozen continent in constant motion beneath the ice. Satellite imagery adds a broader perspective, allowing researchers to track ice sheet dynamics, detect meltwater channels, and monitor shifts in glaciers from space. These technologies, working in harmony, reveal the delicate interplay between ice, rock, and water, helping scientists understand how Antarctica's hidden landscapes influence not just the continent, but the global climate system. The challenges of exploring such an extreme environment cannot be overstated. Temperatures plunge below -50°, winds howl across endless ice plains, and equipment must function reliably despite constant freezing and blizzards. Each expedition is a careful balance of engineering, planning, and endurance, as scientists brave one of the most hostile environments on Earth to gather data critical for understanding our planet's past and future. Through these technological marvels, we have glimpsed ancient mountain ranges like the Gamburtsev Mountains, discovered subglacial lakes that may harbor life untouched for millions of years, and traced rivers of meltwater hidden beneath the ice. Antarctica, once impenetrable and silent, is slowly revealing its story, layer by layer, measurement by measurement. In this union of science and technology, humanity is not merely observing. It is connecting with the Earth in ways previously impossible. We are beginning to see the hidden architecture of a continent that has shaped global climate and ocean currents for millions of years. Every new discovery is a reminder that even in the coldest, most remote corners of the planet, curiosity, ingenuity, and technology can illuminate worlds that were once beyond imagination. Antarctica's unseen landscapes, unveiled through radar pulses, seismic echoes, and satellite eyes, stand as a testament to human determination and to the enduring mysteries that continue to shape the frozen heart of our planet. Beneath the unbroken ice of Antarctica, hidden worlds exist that have remained untouched for millions of years. Subglacial lakes like Lake Vosto, sealed beneath kilometers of ice, are isolated ecosystems that have evolved in complete darkness, under crushing pressure, and at temperatures that would freeze most life on the planet. These extreme environments are more than Earth's frozen mysteries. They are windows into the possibilities of life beyond our world. Scientists study these lakes with awe and caution. Drilling through 4 kilometers of ice requires precision and care, ensuring that the pristine ecosystems remain uncontaminated. What lies below may be microbial life forms that have survived without sunlight, deriving energy from chemical reactions in rocks and water, a form of life utterly alien to us, yet thriving. Observing these organisms offers profound insight. If life can endure in such extreme isolation on Earth, perhaps it can exist elsewhere in the cosmos. The parallels are striking. Europa, one of Jupiter's icy moons, harbors a thick ice shell above a global ocean. Mars conceals frozen aquifers and briny pockets beneath its surface. The conditions within Antarctica's subglacial lakes, though extreme by human standards, are eerily similar. The chemical processes, the isolation from surface ecosystems, the survival in darkness, all these offer clues to how extraterrestrial life might persist in environments that would seem inhospitable from Earth's perspective. Through carefully extracted water and sediment samples, scientists have found traces of microbial communities, some potentially millions of years old. These life forms operate in a delicate balance, metabolizing nutrients slowly, surviving in near-complete isolation. They offer a model of resilience, illustrating how life can adapt to extreme pressure, low energy availability, and freezing temperatures. Tures, conditions once thought prohibitive for biological activity. Beyond biology, these lakes also provide insights into planetary science. The chemistry of subglacial waters, the interaction with bedrock, and the flow of meltwater under ice sheets offer parallels to processes that may occur on other worlds. By studying Antarctica's hidden lakes, scientists can refine the instruments and techniques used to search for life on distant planets and moons, preparing missions that may one day detect life beyond Earth. In this frozen silence, Antarctica becomes a cosmic laboratory, where the most remote corners of our planet echo the conditions of other worlds. Each discovery beneath the ice reshapes our understanding of what is possible, teaching us that life is not constrained to sunlight or warmth, but can endure in the shadows, waiting to be discovered. As researchers peer into these hidden lakes, they are not just exploring Antarctica, they are reaching across space and time, imagining life in places we have yet to touch. The frozen continent, in all its isolation and mystery, reminds us that the universe may be teeming with possibilities, and that the smallest microbial life beneath Antarctic ice could one day answer one of humanity's greatest questions. Are we alone in the cosmos? At the edge of the world, where the wind howls and ice stretches as far as the eye can see, lies Antarctica, the frozen frontier. This remote continent, blanketed in glaciers and sculpted by relentless cold, is more than a vast expanse of ice. It is a living archive of Earth's history, a barometer of our planet's present, and a warning for the future. Antarctica's ice sheets are colossal, holding more than 60% of the world's fresh water. They rise like frozen cathedrals, their surfaces reflecting the pale sunlight, their bases pressing against ancient bedrock. These glaciers are silent guardians of Earth's climate. Every snowfall, every crack, every subtle shift in the ice tells a story of atmospheric changes, ocean currents, and the rhythms of a planet in motion.
As the ice melts, these stories are being rewritten, reshaping coastlines and signaling shifts that ripple across the globe. But Antarctica is not merely ice. It is home to astonishing biodiversity, adapted to extremes that would challenge even the hardiest explorers. Emperor penguins huddle against the Antarctic winter, their cries echoing across frozen plains. Seals dive into frigid waters with unparalleled precision, hunting in darkness, their bodies insulated by layers of blubber. Beneath the ice, subglacial lakes like Vosto harbor microbial life that has persisted in isolation for millions of years, reminding us that life endures even in the most hostile conditions. Each creature, each ecosystem, is a testament to resilience, a living mirror of Earth's adaptability. The frozen continent also holds keys to understanding our planet's past. Embedded within its ice are atmospheric records that span hundreds of thousands of years, capturing the rise and fall of greenhouse gases, the march of glaciers, and the warming and cooling of oceans. Rocks and fossils beneath the ice whisper stories of ancient forests, flowing rivers, and climates far warmer than today. They reveal the fragility and resilience of life, offering insight into how ecosystems respond to change. Today, Antarctica stands at a crossroads. Climate change threatens to alter its glaciers and ice sheets, accelerating sea level rise and affecting ecosystems far beyond its icy borders. Human curiosity and scientific endeavor have brought us closer to understanding this continent, yet they have also underscored its fragility. The research conducted here informs not only our knowledge of climate and biology, but also our preparedness for a world in flux. Antarctica is a mirror, reflecting the intricate interplay between ice, ocean, air, and life. It reminds humanity of our responsibility to safeguard the planet, to respect the delicate balance that sustains both nature and civilization. As explorers, scientists, and dreamers continue to traverse this frozen wilderness, Antarctica challenges us to look beyond ourselves, to marvel at the extraordinary, and to recognize that the fate of this distant continent is inseparable from the future of humanity itself. In the silence of its ice, Antarctica whispers a timeless truth. To understand the world, to protect life, and to foresee tomorrow, we must first listen to the stories frozen within the last great wilderness on Earth. As our journey across Antarctica's frozen expanse comes to an end, we are reminded that this is a land of extremes, a place where ice and fire, life and silence collide in ways both beautiful and fragile. From the teetering Thuait Glacier to the hidden peaks of the Gamburtsev Mountains, from subglacial lakes harboring ancient microbes to emperor penguins braving the brutal winter, Antarctica is a living testament to resilience, mystery, and the forces that shape our planet. Every crack in the ice, every hidden lake, and every breath of life here tells a story of Earth's past and a warning for its future. Protecting this frozen frontier is not just an environmental duty, it is a journey into understanding the delicate balance that sustains life on Earth. Thank you for exploring the secrets of Antarctica with us. Like, share, and subscribe to Mysteries of Earth to continue uncovering the wonders of our world.